Hi, everyone. Last talk, last day. Thank you all for staying here. I know all of your brain is full of a lot of information, so hopefully you can get something out of this talk as well. So as Taylor introduced, I'm Margie. I'm engineering lead at Freewheel. And today I'm here to talk about a very important topic in the world of ad tech industry. So as we all know, the ad tech industry has exploded. Our publishers and advertisers are trying to reach consumers on various screens, OTT, CTV, connected TV, mobile, desktop, and many more. They're trying to leverage new technology to get to the more like a personalized and relevant ads to the consumers. The billions of dollars are transacted in a technology called the real-time bidding. And the key enabler for the real-time bidding is the real-time data. For example, a brand can target their product using a mobile location of your mobile phone. A retailer shop will use real-time interaction on your website, on a website to tailor their targeting. So accessing this data in real time and acting in real time is very crucial for this industry. However, there are so many events generated every second, it becomes challenging to access this data in real time. So today I'm here to talk about some of the key challenges that we are facing in our data team and how we have solved for that. So before that, who are we? We are part of Comcast, which particularly Comcast Advertising, which is a #1 seller of video advertising in US. At Freewheel, we serve ads. We serve ads in the premium content. Some of our biggest customers are NBCU, Hulu, Dish, AT&T, and many more that are listed here. In aggregate, we serve more than 90% of, in aggregate, we serve 90% of top media companies in US and in international. So just to give you a number, we serve daily, on average, 2 billion video impressions through our Freewheel system. Beeswax. So Beeswax is a buy-side platform of Freewheel. They become a part of Freewheel about 2 years ago. They are industry experts in building the demand-side platform for the premium programmatic. So what does that mean? This means that we help advertisers buy the inventory, the ad slots, in most efficient way through our platform. We solve this challenge by in-house implementation that is focusing on transparency, flexibility, and control. So we serve to some of the brands like Indeed, Uber, the tech media companies, agencies, and some of the OEMs. So before we dive into our data platform, let's do basics of real-time bidding, more like an ad tech one-on-one. So a user go on a website loads, the ad slot will come, and of course, publisher wants to monetize on this ad. So they will reach out to their advertising, so their monetizing partner, ad exchanges, more like a stock exchanges, like it's similar to stock exchange. So ad exchange will send a bid request to many demand-side platforms. So in this case, it will come to a Beeswax. Bid request will contain a lot of information, like the size of the placement, type of the placement, whom it is going to serve to, where is it going to serve. All this thing comes in a protocol, Open RTB protobuf. That's the protocol that's used for the real-time bidding. Now, DSP will decide if and what to bid on this bid request, and then sends that bid response to ad exchange. That's where the auction takes place. And if we win the auction, the ad will be sent to the publisher and seen by a user. So this is like the demand and supply, right? So this is inventory. Ad slots are the inventories, that's the supply. And any DSPs is more like a demand for those supplies. Again, this is like very high level of what happens in real-time bidding. And today in this talk, we'll focus on this hexagon, the Beeswax, the demand-side platform. So what happens after the ad is served? Once the ad is served, the event trackers get fired. So and it tracks all the information like impression, clicks, conversions, and all those events will come to an event server. So in this case, it will come to Beeswax event server. It will update some of the information like budget, so you don't overspend, frequency cap, pacing, segment, so you can use the same information for retargeting or exclude targeting. But all those events will come to, now through the event server, it will come to the Beeswax data platform. And that's where all the magic happens. And it will be served to our downstream, which is for reporting or the raw event logs and many more. Again, we'll focus in this purple box here today, the Beeswax data platform. That's where we're going to talk about more. I just want to give like different type of event types that we have. So bid request. Again, like I haven't put all the parameters in this event, but just for simplifying it. So bid request will have a request ID and the creative information. If you win the bid request, it will have a winning prize associated with that. And as I said, once the event tracker gets fired, it will have all the events like impression, clicks. So it will have click URL, the timestamp of the click, event type. And at the end of the day, we want to make a complete record. So join all those events to all the way up to the bid request. So I want to start with giving some infrastructure highlight and want to show some numbers to show what scale that we are dealing with. So like this gives you number on every second, every day, every year. So our event server receives 2.5 million of concurrent requests every second. And from there, like 500,000 of those events will come to our data platform because you're not going to bid on every single auctions that comes to your event server. That comes down to 10 billion event logs every day. We see this number grow every year. Even on the data storage side, we are growing year over year. So I would like to talk about how our small team of data engineering is dealing with the scale in our team. So our data platform is a robust system that collects, organizes, and delivers data. One of the most important consideration in working with the real-time bidding data platform is building a data pipeline that processes processes events for bid, wins, and all the associated like clicks and conversion, everything. So we have about 50 plus data pipelines that generates data for raw log delivery as well as our reporting. Our platform is built for the scalable infrastructure and optimized for cost. So we have various traffic during the day versus in the night. So we should be able to scale up and down. Right, so we architected on the AWS Spot instances, we have auto scaling, we are on multi-region, all those fun stuff. We have diverse set of data stores. So Aerospike is our key value store, Snowflake as our data warehouse, Kinesis, S3, and many more. We also have a diverse set of data offering. So here I'm dividing our data product offering into two sides. One is a raw log delivery on the left-hand side, and on the right-hand side is more on the reporting. So we have streaming log delivery, we have the batch log delivery, we do data sharing through Snowflake, and on the reporting side, we have some reports built on our UI, but we also provide API So customers can build their own reports without even logging into our UI. We have real-time bidding stats that gives you information like, am I winning or bidding and like how my campaign is performing in real time. So why would customer cares about this event log data, right? So event log data provides a transparency into the campaign. And unlike any other DSP, Beeswax provides you can have like unfiltered stream of these events as if like you are building your own bidder. So that's what people are using it. So if you have a data team, if you have a data engineering team or a data science team, you can build your own bidding algorithm and bring it to the Beeswax platform to optimize your campaign. You can also use this data to join with any other in-house, like first-party data that you have that will help you like more like a granular level reporting. You can use it for forecasting and many other use cases. We also have pretty diverse, like this is just like gives you an example of different types of logs, different format, different delivery cadence. I'm not going to go over this table, but it just gives you the variety of ways that we are providing our logs to the customers. We have a reporting platform. Any data team will be supporting. So we have like a data visualization tools. Campaign manager can come to our site and get like a lot more insight into the campaign. I'm not gonna go over like all the different kind of reports we have, but just wanna talk about this one niche reporting that we have, which helps a power user come and say, okay, how my life of bid is doing before I even win or lose that bid, right? So there are like different stages that bid can go through before it decides to lose a bid or you win a bid. So you can match a target. So if you are trying to target a customers like let's say 30 to 35 age group male, are you matching that target? Is your size of the placement matching? So at different stage, you want to make sure that it helps you answer the questions like, do we have enough supply? Are we winning enough? Are we bidding enough? How do we change our strategy? Which makes it very powerful reporting for our customers. All right, so I think I'm going to slow down a little bit because now I want to walk through our data architecture, so our data flow, like how those events are flowing through our system from event server to all the way to the reporting and the event logs data. So here, each box is a different type of. So the yellow box is more like ingestion. Pink box is for our stream writer, and blue box is our data warehouse. The events, as we talked earlier, the event trackers, when the event tracker fires, the events are coming to the event server, right? So clicks, impression, conversion, along with all the auctions and bids, that comes to the event server and flows through our Kinesis stream. Kinesis stream is just like it just gives us the safe handling of the events. Now this events flows through our, it doesn't have the pointer, but it flows through the, it flows through our consumer application, which is, it's basically a Java application written using KCL library provided by Amazon. It helps us write like distributed application without any overhead. So consumer application is responsible for reading, formatting, and routing all those events to various endpoints. One of the biggest endpoints is our S3 bucket. So it's internal S3 buckets we have. as well as external S3 buckets, which is we have like about more than 100 S3 buckets configured, where we write these raw events for our customers. The consumer application is also writing to our to internal and external Kinesis streams. So internal Kinesis stream is a real-time stats Kinesis stream that just gives you real-time reporting on am I winning or bidding, which was displayed on our UI. The stream writer Kinesis stream is responsible for joining those events and writing to our customers using HTTP endpoints. Along with all these places, the consumer application also writes to the Aerospike cluster. Aerospike cluster is responsible for joining these events in real time. So as we said, we want to make sure that each bid request has associated, if there is a conversion or if there is an impression that is served for that bid request, or there is a click for that bid request, and we are joining those in real time in Aerospike. Consumer application also writes to meta markets and Imply, which are just the high-performing analytical tool that just our customers would require for their real-time analytics. Now it's coming down to our the data warehousing side. So we use Snowflake as our data warehouse. We use Snowpipe for our data ingestion. So every time a consumer application writes to an S3 bucket, the Snowpipe will write that to our warehouse. We have a data pipeline, so that just basically aggregates and transforms this event logs data, and those pipelines are returned into Python, orchestrated by Airflow, which will be and make those pre-aggregated tables available for our downstream use cases, like dashboarding, and Antenna is our data sharing through Snowflake, and Redash is just like an internal tool that we use for querying. Yeah, so that's like how our data is, how our bid is flowing from event server to through our all the way to our reporting. So I talked about, as you can see, like we are using a lot of tools in our data platform, but I wanna talk about like why some of the choices that we have made when we decided to pivot. And how it's working out for us. So this is the pillar for our data platform, right? It's a high-quality product, the modern architecture, and the cost efficiency. But we work on some of the guiding principle. So one of the key guiding principle is scalability and efficiency. So as I shown the numbers prior, like we are seeing the year-over-year growth. So we should be able to scale with that growth without incurring major cost. We focus on creating defensible differentiator, so create genuine value for the customers. And for data team, it's basically supporting our customers' needs in whichever way they can work best with this data that we have. We build ad tech, that's what we are good at, and we're okay to buy everything else. So focus our engineering bandwidth on creating the differentiators, and trust the experts in the industry who has built those tools for long, and they are in the market for a long time. Also, time to the market is very critical factor in success to our data platform. We quickly develop, test, get the feedback, and move on. That's kind of like philosophy of our data platform. So just gonna talk about some of the tools that we have and what was our choice, first choice, and why we may move to this the tools that we have. So AWS Kinesis, as I said, AWS Kinesis is like a streaming application. Our first choice was Kafka, but having a small team, we realized that we need to move to something that is easily scalable without having a lot of engineers. So Kinesis is fully managed service. It's pretty easy to set up. Like couple of clicks, you are up and running your streaming in a couple of days. We use Aerospike as our quick, fast, real-time, NoSQL database. And this will help our consumer application, which is written in Java and KCL, becoming a stateless. And Aerospike will hold all those events for a certain number of time and provides exceptional performance for our application. We use Snowflake as our data warehouse. So we started with Redshift, but then quickly pivot to Snowflake just for some of the obvious features that Snowflake was providing at that time, which is distinguishes compute from storage, pretty high security. Their secure sharing is something that we don't have to make multiple copy of our views. We can share our data using the Snowflake secure sharing. Also, their Snowpipe, so ingestion is pretty easy. You can use Snowpipe to ingest our data events to the data warehouse. We use Looker for our reporting. So again, this is the tool that we selected because we just realized that we won't be able to scale for customers' demand. We had in-house UI, which was just I think it was on React, and creating reports. But Looker, when we looked at Looker gave us pretty good functionality. So you can embed those reports into UI. It also provides API capabilities. And some of the obvious one, which is it has very nice visualization tool. It has, you can do version control on your reports. And they're expert in building the dashboarding, so why not just use them? And they have very amazing customer supports as well. So this is just these choices that we have made throughout the system that we have built. So I just want to quickly talk. So as we handle a vast amount of data, it becomes essential for our data platform team to monitor and alert and get alerts on this, if we detect any issues very and promptly, right? So to achieve this, we are using Prometheus, Grafana Cloud, and PagerDuty. So Prometheus is the one that collects all the metrics from each application, aggregates them, and sends it to Grafana Cloud. And we use Grafana Cloud alerting services to send PagerDuty alerts. We have many alerts set up through the system. These are just some of the example that shows aging our messages on the Kinesis stream, right? So you want to make sure that if our messages are staying for longer time on our Kinesis, we get alerted. We have some capacity alerts, some pipeline failure alerts that would be real time telling us something needs to be addressed. What's coming next for us? So as I mentioned, we focus on scalability and cost effectiveness. So one of our application, the consumer application that we written on KCL and Java library, we are on Java. We are seeing some performance issues, and now we are looking into the Spark streaming. Last year, we started moving those consumer applications to Databricks Spark streaming, and we are seeing pretty good performance as well as the cost benefits as well. We're constantly looking into the data quality and data observability, so that we are working with some vendors doing POC and trying to bring this very important. I think that's like a talk of this conference, like data quality and data observability is definitely something that we are trying to get into. I would like to just end with this one statement that a key factor in building a successful data platform team is not having an army of engineering team, but rather focusing on choosing appropriate technology and work on differentiators, unique differentiators for your own product. So that's what we have been doing, and it's working out pretty well for us.